This is dividing decimals less than 1. So we're talking about numbers that are between 0 and 1, like 8/10 and 2/10, like you see on the screen. Please take a moment to get a calculator, pause the video, and type in what you see on the screen, 0.8 divided by 0.2. And for those who aren't familiar with this way of writing divided by, the little slash means divided by. As you go into high school math, you'll see the slash used more and more instead of the division sign you might be used to. So pause the video right now and type this into your calculator and see what answer comes up. Okay, this is the answer you should have gotten, 4. And I find that kind of a surprising answer because 4 is quite a bit larger than the two numbers we started with. So we're just going to take a minute to explain why that happens. And the first thing you need to think about is what exactly division is. Normally when we're dividing, we're thinking about starting with an amount and then splitting it up into smaller groups. And a division question can either be asking us for how much is in each group, or depending on how it's worded, it could also be talking about how many groups we have. So let's put an example up on the screen. Okay, so here's a problem that can help review what division is all about. So the question is, if you have 8 dimes and they are divided into groups of 2, how many groups will there be? So that should be pretty easy to answer just by looking at the screen. We divide them into groups of 2. And how many groups do we have? We have 4 groups. So the arithmetic way to write this would be 8 divided by 2 equals 4. Now I chose dimes for a reason, because we can also think about dimes as decimals, because a dime is just a fraction of a dollar, and we sometimes might see 10 cents written this way. So on something like a receipt, money is usually written in decimal form, so a dime would be $0.10. So let's think about the same question, but we'll think about our dimes as decimals and see what answer we get. So the total amount of money we have represented here is 80 cents. 80 cents is 8/10 of a dollar. 8 dimes is 80 cents, hopefully we know that. And what are we trying to do? So if 8 dimes are divided into groups of 2, how many groups are there going to be? So what we're doing is dividing our dimes into groups that are going to have 20 cents in each group. So that is still 2 dimes in each group. We'll just do that again. There's 2/10 of a dollar, 20 cents. 20 cents again, 20 cents again, 20 cents again. And what are we trying to figure out? How many groups are there? And the answer is the same. So 80 cents divided into groups of 20 cents each group is still going to give us 4 groups. So that partially explains why our decimal question gives us an answer that is larger than you might be expecting. Okay, another way to think about this is read this question from your textbook. So Fiona has a ribbon that is 0.84 meters long, and she's cutting the ribbon into pieces that are 0.07 meters long. So let's just kind of draw this out and see how this question can make sense. Okay, so let's, before we start, just think about what you might expect for an answer. So the ribbon is 0.84 meters long, so that's most of a meter, and she's cutting the ribbon into little pieces that are 0.07 meters long, so those are like less than 1/10 of a meter. So we'd expect quite a few pieces. So right away, I shouldn't be expecting a teeny tiny answer. I should be expecting an answer that's, more than one, and probably quite a few. I just brought in this graphic, and we'll pretend that it's a ribbon, even though it doesn't look like a ribbon. So this is Fiona's ribbon, and she has 0.84 meters. So let's just scribble out that part. That part's not there, it doesn't count, so we're just going to think about 1 to 84. And one way to think about this is, what is 0.84 meters? What's one other way you could write that? So I've just rewritten it, exact same amount, just in a slightly less confusing way. 84 centimeters divided by 7 centimeters, because 0.84 meters is the same as 84 centimeters. And if you don't believe me, just look at a meter stick. So we have our 84 centimeter ribbon, and we're dividing it up into pieces that are 7 centimeters each. So let's just figure out how many pieces we would have. Okay, I'm just going to make some slices here every 7 centimeters. So there's 1 piece, 2 pieces, 3 pieces, 4 pieces. If you know your multiples of 7, this helps. Know where to make the cuts. 5 pieces, 6 pieces, 7 pieces, 8 pieces, 9 pieces, 10 pieces, 11 pieces, 12 pieces. So 0.84 meters divided by 0.07 meters equals 12. 12 what? It's not 12 meters, it's 12 pieces of ribbon, and that helps explain why the answer is a number that's quite a bit bigger than either of those numbers less than 1 that we saw in the main problem. So something to take note of here before we try an example question is I was able to rewrite the problem in a way that basically just eliminated the decimals, and I did that by changing meters to centimeters. So by doing that, I didn't change the actual amount of ribbon we were talking about at any time. I just wrote it in a different way that got rid of the pesky decimals, and that is going to be a strategy that you're probably going to want to use when you solve a lot of these questions. Okay, so here's a sample question. Looks a little confusing. I'm having to divide two numbers with quite a few decimal places. So just to make this a little bit easier on myself, I'm going to rewrite the question in a different way. So we have 0.324. So what that number actually means is 324 thousandths. So the number starts in the thousandths column, and there's 324 of those thousandths. So I'm just going to write it that way. Okay, partway there, what am I dividing it by? How many thousandths do I have in the other number? So I have 9 hundredths. 9 hundredths is the same amount as 90 thousandths. Okay, this is looking a little bit better because I have two whole numbers, but I still don't really like this division very much if I don't have a calculator, because I've got to divide a 2-digit number by a 3-digit number, and I'm not a big fan of that. So let's just rewrite it again. Let's try to make these numbers so the division will be easy. So let's think about how many hundredths we have. Okay, and let's look at the hundredths place value. So for 0.324, these are the hundredths. So what I actually have here is 32 hundredths, and then these 4 thousandths left over. So the way I would write that in a slightly different form is 32.4 hundredths. And the other number is easy. I have exactly 9 hundredths. So let's add that in. Okay, I do still have a decimal kicking around, but this is division that I like a lot more. And it doesn't matter about the word hundredths. I don't have to get freaked out about that. This could be anything. It could be 32.4 kittens divided by 9 kittens, although I don't know why you would have 0.4 kittens. So don't even worry about hundredths. What we're really doing here is dividing 32.4 by 9. So let's divide that out. Okay, hopefully you remember your long division. If not, we can do a bit of review on that in class. It's best to set it up like this. So 32.4 divided by 9. 9 goes into 3. How many times? It doesn't. So we look to the next place value. 9 goes into 32 3 times, and 3 times 9 is 27, which tells me I have 5 left over, and I have to bring down the 4. Now, you might remember this from grade 6. When we're dividing and we have a decimal, we have to put it up here. We're now going to decimal land by bringing down that 4. So remember to add the decimal point up there, right above. 9 goes into 54 6 times. 6 times 9 is 54 exactly, so we have 0 left over, so we are finished dividing. So this gives me the answer here, 0.324 divided by 0.09 equals 3.6. Another way to say this is 324 thousandths divided by 90 thousandths equals 3.6, or 32.4 hundredths divided by 9 hundredths equals 3.6. So we've written the question in 3 different ways, but they all give us the same answer. Okay, now I'm going to teach you a little bit of a shortcut, so you don't have to be rewording the question each time and thinking about hundredths and thousandths, which can get a little bit confusing if you're not totally up on your decimal place value. So here's the little trick we can do. So this is the question, and I want to just quickly rephrase this question to get rid of the decimal points. So I am allowed to move the decimal point as long as I'm doing the same thing to the top and bottom. Just like with fractions. Now what this really represents, that slashy line means divided by. It's just like a fraction. So this would be pretty much the exact same as 0.42 over 0.07. I'm allowed to do the same to the top and bottom. So I'm allowed to do the same operation to both sides of this division statement. So what I'm going to do here is, in my mind, I'm going to imagine I'm multiplying by 10. And when I multiply by 10, what I'm doing is moving the decimal place over 1. You can try that on a calculator if you don't believe me. So now the decimal place is here between the 4 and the 2. And I'm going to do the same thing on the other side. I'm going to move the decimal place over by 1. And now the decimal place is there between the 0 and the 7. But that still doesn't help me that much, so let's do it again. Let's multiply by 10 again. And we're going to move the decimal place over one more time. Now it's there. And we've got to do the same thing to the other side. Multiply by 10 again. Imagine you're doing this. You don't actually have to write it down. And we're going to move the decimal place over by one more spot. So now it's at the end of both numbers. So what I have here is 42.0, but I don't have to write that. We don't have to write 0. Divided by 7. And I'm hoping this is division that you can kind of work out in your head. If you know your multiplication facts well enough, you should know that 42 divided by 7 equals 6. And this answer applies to the original question. 0.42 divided by 0.07 equals 6. And you could also think 42 hundredths divided by 7 hundredths equals 6. So this is the trick. Get rid of the decimals and it makes the division much, much easier. Okay, here's a sample for you to try. 0.96 divided by 0.12. Could also phrase this as 96 hundredths divided by 12 hundredths. Being a little bit cruel here because it's 2-digit by 2-digit division, but I think this one should be easy enough that you might even be able to do it with mental math. So pause the video, and in 3 seconds I will show you the solution. So right now you should be taking out a piece of paper or something to write on and trying to solve this. Okay, we're back. Here's the solution. So 96 hundredths divided by 12 hundredths. The easiest way to solve this quickly is to move the decimal place. So I'm going to move this decimal place over 2 spaces. Now it's right there at the end of the number. And I'm going to do the same for the other decimal place over 2 spaces. It's right there at the end of the number. So my new equation here is 96 divided by 12, which you hopefully can do with mental math if you know your 12 times tables. The answer should be 8. So that tells me that 0.96 divided by 0.12 equals 8. Okay, if you're looking at this and you're finding it confusing why the answer would be a number like 8, think of money. And that is a good rule of thumb for decimals because we use money a lot, we're fairly comfortable with it, and we're used to expressing money as decimals. So think about this. Okay, so let's think about it in terms of pennies, because a dollar, if we divide it into hundredths, those are pennies. I know we don't have the penny anymore, but we can still imagine pennies. Maybe students who are watching this a few years after it's made won't know what I'm talking about when I say penny, but for now, hopefully you do. So if I have 96 pennies, and I divide my pennies into groups of 12 pennies in each group, how many groups am I going to have? It should be 8 groups, and if you don't believe me, go find your parents' jar of pennies and try it out.